Morning, everybody. Thanks for coming along. More people, the better, to warm up the room. It's nice and cold. Thanks for the intro, Claire. I'll talk a little bit about the work that I do with the different organisations. So W3C is the group that defines the standards essentially for the web. The Kronos group really represents a lot of the silicon manufacturers, so focuses more at the chip layer of the integration there. And then the ISO is working on a reference model for augmented reality, so people can have a reference model to develop against. And so we spend a lot of time working on how open standards and open data formats can work with augmented reality. What's been holding us back is a lot around that, and I'll talk about that as well. And a lot of our work is focused on taking these bleeding edge technologies and applying them and working out what the real opportunities and the real limitations are. So I'll talk through what we've done is applied the dream, dare, do to our story, and so I'll walk you through that. So we started with a dream. We really wanted to build our own reality. So we love AR, and I'll talk a little bit about the definitions of that in a moment. And we really wanted to be able to explore that for ourselves. There's a whole lot of interesting things, not just at the tech layer, but in the way that it affects the way that we think and the way that we perceive space around us and the way that we communicate with others. So we really wanted to focus on that as a research area because we find it really interesting. And so we dared to build our own platform. And so the first thing we did is in 2009, we launched BuildAR, which was the first self-service web platform. And the idea was to make it possible for anyone to create augmented reality. Up until then, it had really required a lot of dev skills, primarily around C++ or Java, to compile an application, build it, and make it work. So we made it possible so you could just go to a web browser, click around through a map interface, those sorts of things, and start adding augmented reality content. And what I'll really focus on through the rest of the presentation is the do aspect, the execution that we went through, what we've learned from this, and how all of the different technology components fit together and where the landscape is up to at the moment. So we really want to share our story of how we've put these things together and why we believe right now it's just on the verge of mass adoption. So what is augmented reality? Since the early sci-fi movies, there's been a lot of representations of information overlaid onto reality. And so one of the first ones that people really pointed to was called Terminator Vision. So Arnie would be looking around a scene and he'd recognize something, some options would show up, and some information would be overlaid onto his view. In 1990, Tom Cordell was working at Boeing. And so he was dealing with that same sort of thing. They were definitely exploring how pilots could benefit from information in the cockpit because of the information overload. But the real problem that they were facing was the engineers servicing the planes. The service manuals are sort of a stack of books about that high. And so there's an overwhelming amount of information, but it's really important that these planes are serviced correctly, obviously. So they were working on different ways of presenting this information in in situ, in the real context of where you're working. And so Tom coined the term augmented reality, and it really stuck after that. There was a lot of different media representations, and one that people really commonly point to is the Minority Report. Maybe it's Tom Cruise, I'm not sure. So this was really showing a gesture-based interface, a really immersive, rich media experience. And so this is something that really captured people's imaginations as well. But now you're all really familiar with this sort of thing. We use these tools all the time. I'm sure most of you have tried some sort of AR application on your phone, or certainly location-based information as well. So it's really common to see applications that lay out information around you onto your view of the world, and it's just pulling in location-based info. I'm sure you guys are really familiar with that. It's also possible to buy off-the-shelf cars now with built-in navigation systems. So they display things that optimize your driving. And there's been some really interesting research. I think it was Toyota? Yeah. Anyway, so there's a lot of research around how this sort of information can change the type of driver you are. So they've found that by presenting cues for navigation and cues for risk, they can make more timid drivers more assertive and more aggressive drivers more calm. So by having consistent information, it really seems to tone people down to a more middle ground. So these sorts of systems are available now. And of course you can use different applications to visualize things like putting furniture in your home so you can see how it would look. IKEA is a great example of that. And there's a really wide range of applications now that lets you visualize products and specifically furniture and homewares in your home. And it also lets us explore impossible things. So there's a whole range of things that are either too dangerous or just not practical. So, playing with the brain is obviously one example. So AR really lets us explore things that are impossible or just not safe to do. And these science fiction interfaces really are starting to become fact. So it's at the point where we can really now start weaving these into real experiences. The things that we've seen in the movies really are starting to be possible now. And one of the things that I really want you to take away from this is we can now start to open up our imagination and really dream about the things that we want to do. Up until now, there's been a lot of technical limitations, and we're still going through some of those. But by the time you build projects, the technology has changed, and it's moving so quickly now. So I was at Augmented World Expo. That was the conference in Santa Clara. I've been going there every year for 5 years, I think it is now. And every year it's been getting bigger and bigger. This year there was about 3,000 attendees. There was about 200 people that attended by robots. So there's a robot you could log in from your laptop and then steer it and drive it around and interact with people from that. It's kind of disconcerting to be sitting in an environment like that with a whole row of faces behind you. And you can turn around and actually wave and talk to the people on the screen. So it was quite an experience. But it's really, the market's really changed. So there was now 3,000 people, but there was a lot of big companies attending. Boeing, SAP, Citrix, Disney, Johnson & Johnson, just a wide range of people. And they're really applying this in their business context now. It's no longer the sort of hypeware that it was before. And it's not just being used for advertising and marketing anymore. The challenge with that was people wouldn't return to those experiences. They were like empty calories. You'd go, oh, that's cool. Or most people would actually watch the YouTube video rather than trying the experience. And then they wouldn't come back again. But now we're seeing people applying this with real utility and real usefulness. So a lot of people ask, wasn't AR just a fad as well? So there's a perception that, these technologies go through like fads and waves. Paul Sappho has a great point about how technology evolves. So looking at this line up through the middle, this is really the straight diagonal line. That's really our expectation or perception of what technology should be. So for each new technology, we'll have a fairly linear expectation, and we just expect it to just increase and keep getting better. And we find that in the early phase, this blue line is the reality of what's actually delivered. So you'll see in this phase, there's quite a big gap between what we expect and what's actually delivered. And it starts off really, really slowly. But it gets to a certain point where it passes that. All of our expectations are tracking along about the same, but the acceleration in the technology has increased so much that it starts achieving what we expected. And our belief is that AR is about here right now. It's a really important point, and everything is in a state of change at the moment. So it's really important to not think of these technologies as fads that wave through. That's more around our perception of them. And I think if we're implementing strategies for these sorts of things, it's great to keep this in mind for all the different technologies that we deal with. But one thing is that AR is only a small slice of the whole picture. So what we're really talking about is two broad areas of computing: pervasive computing and mixed reality. I'll focus on mixed reality for today. So this is a continuum presented by Paul Milgram in 1994. And what it does is it shows the range of different relationships between the real world over on, I think, your left side over here, and the virtual world over this side. Now, inside the social sciences, there's a whole lot of debate about if there is really a fragmentation between those two. But in reality, you can have, let's take the examples here. So there's a real person's head over this side and a completely virtual head over this side. And then you have shades of grey in the middle. So augmented reality is really here where you're taking a real object and overlaying digital information onto it. There's another thing called augmented virtuality, which is taking a virtual object and then maybe presenting video of the person's face onto that object. If you put video into Second Life or those sorts of things, that's really what this slice is. But most people focus on this area where they're seeing the real world and they're overlaying digital information onto it. So what is virtual reality? Virtual reality was a term coined by a French poet in 1938. And in 1962, Morton Helig created the Sensorama. If anyone's got it, $1.5 million, it's for sale now. But basically, it was a Coney Island sideshow sort of ride. So this is it here. You sat in it like this, and you stuck your head in it and had a screen. He was a filmmaker, effectively. And it lets you drive through Manhattan on a motorbike. But what it did is not my hair, but it blew wind in your hair. And it also used smells and aromas, all sorts of things, sounds, vibrations. So it was really for the first virtual experience. But 1962, that was a long time ago. In 1968, Ivan Sutherland developed this head-mounted display. So this was a binocular vision system. Each of these two eyes were receiving independent images rendered by a computer. The graphics back then were quite primitive, but it was quite compelling. And he called it the sword of Damocles because all of this equipment was hanging over your head, obviously. And you can see how massive and how primitive this was. But 1968, that's quite a long time ago. In the 70s, 80s, and 90s, Tom Furness completed some amazing work that really extended VR even further. He did a lot of work for the Department of Defense. He was focused on cockpits and the information overload there and how you make an integrated scene. So the problem that they were dealing with was, I'm not much into weapons and war and that sort of thing, but they were focused on planes being a delivery system for weapons. And at that time, the way that they would steer the weapons would be by steering the plane. So you'd point the plane at a thing, and that would be where your weapons would go. But they had much more compelling targeting systems. They just couldn't, the pilots couldn't drive that because there was something like, I think, 83 different computers or some ridiculous amount. So what they developed is there's this big Darth Vader fly sort of helmet. And it created this sort of environment where they had a VR view of the world, and it pulled out all of the key landscape elements, the features. And the pilot could just point and tap at different areas, and then you could interact with it like a scene. So it wasn't really where you were steering the aircraft. It was much more of a God's eye view, interact with it. And that really had an amazing impact on the performance of the pilots and their ability to cope with the stress of that. Tom's done some amazing work, and he went on to found the HIT Lab, which is a global network of research labs. So I definitely encourage you to check out his work as well. And then in the 90s, so yeah, things got a little hairy. Jaron Lanier became the poster child of VR in the 90s. He's a musician and a programmer, and he really focused on using VR for creating music. And he created some great experiences. It really built up a lot of the hype, and I think he suffered from that. At one point, Nintendo made this Power Glove, which is what he's wearing here. So it was an interactive gesture tracking device in the 90s for playing video games. It was actually shipping, and you could buy it at Toys R Us. Didn't go anywhere. So I think what Jaron really suffered from was in the 90s there was a whole wave of media, things like the Lawnmower Man. It really hyped up VR and showed, this spectacular view, often quite dystopian view of what was going to happen in this environment. But when that bubble burst, it really led VR into, basically into the desert. There was a long dry period where VR was uncool. It wasn't something that anyone focused on. Silicon graphics and those sorts of companies had died down. It really wasn't something that people were focused on. But since that time, certainly over the last couple of years, there's been some amazing developments that have happened. So if you look at the Kickstarter project that Oculus launched, they basically wanted to rebirth the industry. And the thing that's come out of that is the Oculus Facebook buyout. So I'm sure you're all familiar with this if you haven't. So Mark Zuckerberg paid $2 billion to buy Oculus. This has had an amazing kickstart effect on the industry. So when I was in the Valley a couple of weeks ago, it's just an amazing bubble again. Everybody's focused on VR. I think VR is just a slice of the mixed reality continuum. But there is so much activity going on, it's literally crazy. So as you can see, it's really possible to draw a clear line between AR and VR. But who really cares? Most users don't care. They just go, I want some magical stuff. In fact, a lot of technologies they'll misname. They just want digital magic. They want a cool experience and they want things to be useful and have an impact on them. So let me talk through why there's a fuzzy line between the two and how this is really changing in the marketplace at the moment. So in 1833, Charles Wheatstone created this device, which is called the Stereoscope. Basically, there's two separate images that are created by two cameras not very far apart, just like the 3D filming we do nowadays. And there was lenses, and you'd hold it up to your eyes. It was basically an early ViewMaster. And from that, people could see a 3D perception of a scene. And back then, that was a pretty compelling experience. That was multimedia. So what we've done nowadays is we've done exactly the same thing. But instead of using the two stereo photos, we just put a phone there. And it works really well. So you can render two slightly different views of a scene on your phone. And using these sorts of devices, you can get a full VR experience. But of course, it doesn't have to be in the Stereoscope format. There's a really common format now, which is called cardboard. Basically, cryptically called, I can explain why. But basically, Google have kind of popularized this, but it really can work with any application that can render these stereo views on the screen. Inside here, you have two small lenses. They're really cheap lenses. We can buy them for something like 15 or 20 cents each. So you can make this sort of thing for, under a couple of dollars. But this whole space is exploding. There are literally one of these new, we call it mobile as a mask, because basically you're strapping a mobile phone to your face. So one of these mobile as a mask carriers or devices is announced at least once a week. And so there's all sorts going from the lower cost cardboard ones right through to the high end. This is a Gear VR. So a couple of dollars for these, I think $300 for these. Basically, you strap a device in the front, and it just works like that. There's some really cool ones in between. These are called Go4D, which are from a Korean company. It's $20. And basically, they just clip onto a screen like that, and then you look into them. And it looks kind of primitive, but when you put it on, it's surprisingly compelling. We can bring up some examples later. So really, now you can just slip between your mobile and a wearable device, as comfortable as slippers. It's fairly easy. This isn't the sort of experience that people are going to spend hours and hours and hours in. The higher-end VR displays, people will probably spend a lot of time gaming. But in these sorts of experiences, they're the sort of thing people will use at schools, use in small companies. People will carry around small devices like the Go4D, pull them out for a 1 or 2 minute experience, and then they'll go away. But the key thing is you can also just use the exact same experience in the phone. You don't necessarily have to go into the VR. So you can switch between. Some people don't have stereopsis, so they can't see clearly through both eyes. I have eye dominance, so I definitely have challenges with that sometimes. But yeah, this technology is spreading really, really quickly, and is probably the thing that's going to transform this space the most because it's such a democratic or democratizing technology. So I believe of the cardboard devices and the apps, Google have already shipped over 500 million of those. So it's a real installed base. So what are wearables? This leads us on to a nice segue. Wearables, people have been wearing computers for a long time. So initially, I think this is the international unit of measure called a boy band. So there was about a boy band's worth of people wearing them. This is Thad and Steve Mann and those guys back at MIT in '95. I think it took real balls to walk around looking like that in 1995. And certainly Steve loves a good policy debate. He loves a language debate. He'll like to twist words around. But then he also loves a policy debate. He got kicked out of McDonald's in France because the security guard said you're not allowed to film in the premises, and he got into an argument about how they were filming him with the CCTV cameras, and they tried to take it off him, and he had a letter from his doctor saying it was physically attached, you're not meant to remove it, and yeah, Steve loves a good media blow-up. But since then, wearable technology has come a long way. There's probably a lot of people in this group already wearing wearable computers, but we don't think of them so much like that. This is, the Fitbit and activity tracker. These are really common now. The reason that we believe that wearables and mixed reality works so well is often these devices, there's two categories really. There's a wearable display, something that you'd put in front of your eye or near your eye and help you see the world in a different way. But then there's also devices that have minimal or no interface and are just strapped to your body in some way. And AR gives you the ability to project information that's coming from these devices and then create virtual displays so you can have a much larger interaction. And that works with the whole Internet of Things as well. There's a whole lot of objects probably in the room that you could reach out and grab information from, present information over, but they may have no physical display. So it's really like we can peel the user interface off these hard objects now and put them in the network. The first examples of that were really Wi-Fi access points, something that had, maybe one or two buttons, if that, and then most of the configuration was done via the web. This is something that's really spreading with the visualization of interfaces through AR and then interfaceless objects like wearables, nearables, and Internet of Things. So I'll just walk through a little bit of the history of wearable tech. This is a great overview provided by Mashable, and let's just walk through this. So the history of wearable technology goes back a lot further. So I think there's certainly examples of, in the early Chinese dynasties, people wearing abacus-based rings. But what this focuses on is digital technology. So we're starting in 1961, and Edward Thorp created this, basically a gambling device. So it was a way for him to cheat at roulette. And he did this, he co-developed it with Claude Shannon, who's the father of information theory, for any geeks in the audience. This gave them an amazing edge, a 44% edge in the game. That's really amazing. And 1961, again, we're talking about those times of sort of the Sensorama and sort of Damocles head-mounted display. In 1972, Keith Taft created another wearable device, and again, this was focused on gambling as well. So he wanted to take advantage in blackjack. There's the thing about rapid prototyping. He lost a lot of money. So that one didn't go so far. In 1975, we moved on to the Pulsar Calculator. This is a big, large device, and even then the focus on celebrity for marketing showed how important that is. So allegedly, Gerald Ford expressed interest in getting one, but back then, $3,900 for a calculator basically on your wrist, that's a ridiculous price. In 1981, that's when Steve Mann started wearing these sort of devices. So he was wearing what's effectively an Apple II strapped to his back, and he had a lot of TV equipment as well, so he really focused on broadcasting and rebroadcasting TV signals. So he was definitely one of the early pioneers. And then 84 was the Terminator Vision that we saw the scenery of earlier. And so, yeah, predicting the dawn of Google Glass, but we'll talk a little bit about that in a while. So in 1987, the first of the digital hearing aids were released. And that would have been a really, in fact, my nephew wears one, and it was a really life-changing event for him to have them installed. So this is an amazing wearable technology that's had a huge impact. And really, that wasn't that long ago. And then Steve Mann continued evolving his wearable devices and fashion sense. So life logging was Steve's explored a lot of different terms for these sorts of things. Life logging was one of them. It's kind of grown into what was an area called the Quantified Self. Some people still follow that, some don't. It's really around, just creating data about everything in your life, how you sleep, how you walk, how you talk, everything. And then 2000, who's got a Bluetooth headset? No. There's a lot of utility in those, and you see specific context. I still wear mine running. You see, a lot of couriers and those sorts of people wearing them. But, there's a real balance between social acceptability and these technologies, and we'll talk a little bit about that in a moment. In 2002, Zybernaut Poma wearable PC was launched, and the description of it's pretty apt, I think. So it was a computer that retailed for $1,500 and all the sexiness of a cassette player strapped to a headlamp. And I think that's a lot of what we've been struggling with, is the aesthetics and the form factor. We're still quite a way off on that being a mainstream technology yet. 2003, C-Series, first digital pacemaker again. Now, there's a whole category. Wearables are the broad area. Things that are more close to you rather than on you, people are calling nearables now. And then things like this is a really embedded system. So, I think this is going a step further beyond wearables. In 2006, Nike and iPod teamed up, and that was the first real mass adoption of, pedometer, activity tracking sort of technologies. From there, it moved into the Fitbit. And so Fitbit is now, depending on your measurement, effectively 60% of the wearables market. They have shipped a lot of devices. And I think the thing is, they're not pitching it as a wearable computer. They're just trying to deliver some functionality, something that's useful that everybody can relate to. And then 2009, again, another horrible, expensive wearable computer. Then the Pebble evolved, so the whole watch space is really developing even further now. Samsung have released some interesting things. I think watches is a real... there's a really interesting category, and really we need a mesh of devices to interact with. The problem with things like glass, so glass is really a point of view, outward facing camera. So if you try to do video conferencing with somebody, it's impossible. They're only going to see your view. If you're doing a service call or something like that, it's great for them to be able to see what you're seeing. If you're doing a social call, they want to see your face. So you really need something else. You may have a phone, but it's also easy to have a camera on a watch. The form factor is getting pretty small now, so being able to just do that is much easier than standing in front of a mirror or something like that. So Google Glass. I spent about 4 or 5 months wearing glass a lot. We had 3 pair, and we spent a lot of time doing research on it. It's a great technology, and it really does have a big impact. But actually, I'll dive more into that in a little moment. So, yeah, 2014 was termed the year of the wearable, but I think we've learned a lot about some of the challenges and shortcomings since then. If you really want to get a good overview of the wearable space, check out Banterisco.com. They're a Canadian company, and they run a database of all of these devices. They break it down. So they'll tell you based on, there's 11 categories on the body, how many devices are for each of those parts of your body, and they talk about the types of sensors and devices in them, the price. It's a really good overview, and it's been running for about 8 years, so it's a really good quality database. So let's look at some of the things that have been holding AR and wearables and VR back. So one of the things that we've really learnt since sort of mid last year is some of the challenges that face Google. So there's a large backlash around privacy. The fact that you have a camera on your face is so conspicuous, it really has an interruptive effect on your social interactions. So, I've worn glass in all sorts of contexts, from, filling up a car, going and getting something at the shops, into meetings, conferences, those sorts of things. It really gets in the way of your conversation, and it's more about people's perception of the camera than almost anything else. There is a certain amount, something blocking your eye. It's a really interpersonal thing to put something between your eye and the person you're talking to. But if anything, I believe it's mostly about the camera. People, there is very little difference between the camera on here and me being able to take video of people and strapping one to my face. But it is so conspicuous, and it has such an impact on your social interactions that I think there's something they've really struggled with. And so the perception now is that, you're some sort of spy bot. There were a whole lot of places that were already, the term glass hole sprung up, and there were places banning glass holes, so even when they weren't shipping, The other thing is the value exchange. I love this photo. One of the most important things with technology is there has to be a great value exchange. Every user who uses a technology has to invest a certain amount of themselves, a certain amount of activity, and they have to get back equal or better value. Glass is a great tool, but it's not really providing that value exchange for consumers. I think there's a good chance that Glass are going to relaunch very, very soon, and I think there's a chance that they'll refocus on the enterprise market. There's a lot of companies. So at the conference that I just came back from, there was a whole segment on head-mounted displays, wearable glasses basically, and there was 8 vendors, excluding Google, that were covering their latest developments. There's some companies like Vuzix and Optivent that have been doing this for a long time now. Vuzix and SAP are shipping a lot of devices into logistics and infrastructure sort of context. So, there is some real benefit there, and if it improves your job, improves safety, there's a real business benefit. But I think it's going to be a little while before we see this from a consumer perspective. People like Optivent are trying a different form factor. They're going with headphones that you can then bring down head-mounted display. But again, I still think it's just too invasive. There is an amazing system that Google have released called it is a contact lens, but it's nothing like Google Glass. All it is effectively a single pixel, not much more than a single pixel, and it measures the glucose levels from your blood through the moisture in your eye, and from that, so if you have diabetes, you can have almost a visual indicator, and you can track your blood or your sugar levels. So like that sort of thing. To me, that makes perfect sense. There's a great value exchange. It's minimally invasive. That seems like a really good fit for technology. But again, I think wearable glasses are going through that same sort of double or S-curve that Paul Sappho was talking about before. VR's gone through that. AR's gone through that. This is deep in the middle of the bottom hump. People's expectations just aren't being met. But I think pretty soon we're going to shoot out the other side. And then the other problem, so with native applications, AR is primarily shipped as native applications, and I'll talk more in detail about that in a moment. But the biggest challenge with that is getting there. So we call it from know to go. So from somebody just broadly knowing that there's something that I can interact with in the world to actually interacting with it on my device. If you look at some of the, not to pick on them, but one of the mainstream AR browsers called Layer, they have pretty good user experience, I think. But to go from being told by somebody in some print material or a sign or something like that, to go to the app store to download it, to start interacting with it, search, find the content you want, go through the first use experience, it's 17 steps. That's a massive distance. We measure the distance between you and an interface in a number of different ways, based on the network speed, the number of actions taken, the number of steps to access your device. And so we really measure this as like a geometry. It's how far away do you feel from an application or an experience? And at the moment, that gap is just too long. So at each of these steps, there's a fall-off rate. 17 steps, you're getting to like 90% fall-off rate. So this is a really big challenge. And another big question is how many people are really using AR? So there's a industry stated goal from Maury Enberg. He's kind of driving this. The goal is to have 1 billion regular users as soon as possible. Their sort of stated goal is 2020. But if you look at where the mainstream AR browsers are, so bless you. These are the three mainstream ones. Geneo is run by a German company called Mateo. They were recently bought by Apple, so this one's kind of gone away. Wikitude, which were really the first into the marketplace. They've built quite a good momentum, but the ones that really have won through OEM deals, they've done deals with Samsung. There's a whole bunch of Samsung devices that ship with Layer installed on it already. So they've got up to 10 million. So if you look at the total of that, 11.5 million, that's a long way short of the 1 billion users that we're aiming for. So there's got to be a better way to access that. Our view is that you can surf the web. So we started in 2009 by making content creation available through the web. But what we've been really working on since then is how do we use open standards and web standards to make the experience itself run inside the web browser. And if you add these new technologies, these new standards, and I'll talk through those in a moment, you really do turn the web, the traditional web, which now was Web 2.0, into a rocket that is just a whole different experience. And if we look at the size of the market, it's much, much bigger. So this is the slice of browsers that support the new technologies that we need to deliver AR. So if you look, this is already 14 times bigger than these other installable apps. And the thing is, these browsers are already installed on the devices. So these numbers don't represent the whole market. This is just the Android slice because they're public data. So if the iOS side is, depending on the audience you're talking to, Australia is quite a high iOS-specific audience, but there's normally roughly a good balance between the two. But these are public numbers. You can check them on the Android Play Store. But the important thing is I put that slide together about a year ago. Right now, it's grown to 600 million. So the default browser on Android runs these standards. But if you look at the other browsers in that period, they've flatlined. They haven't evolved or grown their market space at all. So we really see and have always seen these installable app browsers as a transitional silo. They really do create separate silos. You can't create content for one and then run it in the other. There are real interoperability problems. And from our perspective, it's kind of the equivalent to where AOL or Apple eWorld were before the web came along. It was, a great experimentation. It was a great way of getting people involved, but it wasn't where the main game was going to be. So 600 million, that's a really a big addressable audience, and that's available right now. So what does the augmented web look like? So that's the term that we use. So we've basically taken the web, added on all the standards we need to add AR, and we call that the augmented web, or these are augmented web experiences. So this is the major benefit of the web. This is what Tim Berners-Lee's major innovation was the href, the link. You could send a link to somebody and they just open it. It's a universal way of sharing content, and that's the biggest advantage the web has over native applications. The augmented web is exactly the same, but it's just what happens when you click on it can be much, much more compelling. So if we look at which browsers support these augmented web experiences, it's pretty mainstream already. So Chrome is driving the market. They obviously have the largest installed base. Firefox has a large installed base, and Opera is effectively built on the same platform as Chrome. So if you look at these provide the bulk of the market, depending on the audience you're talking. If you're talking about consumers, Chrome by far is the largest audience. If you're talking about enterprise market, banking, those sorts of things, IE is definitely the main for those. So if we talk about those other platforms, iOS, Safari, you can run a lot of these technologies. Actually, let me talk through what the standards are. There's about 10 or 11 different web-based standards that we require. The first is, obviously, you need JavaScript, so you can run interactive script-driven content. The second is that you need some sort of 3D representation. So the mainstream web standard for 3D graphics now is called WebGL. So it just allows you to deliver great 3D content as compelling as any of the native applications. And then on top of that, we need to be able to sense how the devices are moving. So we need things like GPS, so we can work out roughly your location, and we need a gyroscope and an accelerometer, so we can work out how the device is moving through space. And then on top of that, we need to access the camera and the microphone. And so this is one of the things that's really changed. One of the new technologies is called WebRTC. Stands for Web Real-Time Communication. Effectively, it was designed as a video conferencing sort of replacement. So they're targeting that sort of Skype, FaceTime market. And Skype and Hangouts. Oh, sorry, I was thinking of the Google one, Hangouts, yeah. So most of those platforms are integrating so they can talk WebRTC and interact with that. Now, if you look at Firefox, you'll see in the top corner there's a little smiley face. If you click on that, that's a video conferencing platform. You can just send someone a link and your browser just starts video conferencing with them straight away. These things have really opened up the technology massively. And with these video streams, it's really different from how the web treated media before. Before, you could place a video on a page and then you could go play or stop. This is completely different. Now with these streams, and it's both the microphone and the camera, we can reach into them, access each individual frame, and walk each pixel and process them in real time. It's amazing. We can actually really, in JavaScript, in the browser, create real computer vision. And this is one of the big strategic changes. So traditionally, we've been more around managing boxes and networks, and then from that, people have focused on to building APIs. I think that's a great thing. We've done a lot of that for our enterprise customers. But the real strategic challenge that's happening now is the management of streams. So how companies create tools that sit on top of streams, extract value and meaning, I think that's the next business challenge that people will really be focused on. So that's WebRTC. That gives us the camera and the microphone access. These all put together give us all the tools we need. So iOS and Safari in general doesn't support that yet. It supports the WebGL, supports the gyro and the compass, but it doesn't support the camera access yet. So that's one of the big slices that is yet for to roll out to the market. And if we look at the Microsoft space, so Microsoft's got good support for WebGL and the different sensors now. They have they understand the significance of the camera and microphone access, WebRTC, and there's a bit of a battle playing out around that at the moment. But they're definitely engaged in supporting that, but probably at the next version. So this is so what I'd like to do is jump to a couple of videos that just show the types of interactions that you can see in a web browser. And the key with these things is they are just things you can tap on a link and start experiencing it. Let me show this first one. Oops. So this is literally just a camera view in the background and using the gyro and the compass. So it's worked out where I am. And as I look around, I can see normal GeoAR content around me. But one of the challenges with that is it's always been at the center point looking out. But now with our new approach, you can actually zoom into models and walk around them. So it can be much more interactive, and you can create these sorts of scenes. So this is just some rough examples, education, games, marketing, those types of things. It can create all sorts of interactivity. So this one's basically when you tap on the guy, he shoots a ball at you, and we can shoot back the other direction. I'll show you some examples around that later. And, the models, it's got the ability to pinch and zoom, so you can zoom right into it in the car in a second. You'll see we go right in and almost sit in the passenger seat, look around, and then you can go back out. So this is just one of the modes that can be supported, but, this looks like a native application. This is the sort of experience people expect from AR. And so Yeah, the focus really is on how the web itself can now be blended with the physical world. So what I'll do next is show a different video. This is a demo that we're about to release. This hasn't been released yet. And this really pushes the network and the devices to their extreme. So what this is effectively kind of like a Minecraft sort of experience. So you have an island in the middle here, and these are the blocks. On your device, as you point around, you have like that green block here is the cursor block. So as you move it around on the island, wherever it is, if you tap on the screen, it'll add a block there, or you can go into delete mode and delete one. So you can see this was Alex using the device and just moving around, and you can walk around the island physically and, build these sorts of interactions. But one of the really key points is that you can then invite a friend in and they can interact with this in the same way. Sorry about the face. And you can shoot them, of course. So really we're just showing the different types of interactions and throwing this open for people to play with it while we prepare the next release of our platform. But this is great for all sorts of contexts. So educational contexts, people sharing models, talking about ideas, just being able to share someone a model of something you're going to put into place or situation. They can tap on a link, walk around it. If you want to talk about it, you can bring them in and chat. And then all sorts of interactivity as well. So this gives you a good overview of the sorts of experiences. Depending on your context, some people may think this is VR, some people may think it's AR. We can switch on the camera view in the background so you can see the world as well. But again, users don't really care. It's about the value proposition. Is it useful? Are they actually going to use it? So that's my overview of AR, VR, wearables, and how we believe this is going to gain really wide distribution.